So that was the magnitude is equal to minus 3 square plus 70 upon 13 whole become 9 plus 4,900 upon 169 whole under root. Come under root 6,421 upon 169. That will become 80.1311 divided by 13. The final answer is 6.164. This is the final answer, the magnitude. First we wrote in component form, then we wrote the magnitude. So that was question number 8. Now in exercise 9 to 16, find the component form of the vectors PQ, where P is 1, 3 and Q is 2, -1. So we will do as we have already done. The PQ will be equal to the components of Q minus the components of P. So, and we will write in IJK form, in this form. So that will be the component form. The vector OP, where O is the origin and P is the midpoint segment of RS, where R is 2, -1 and S is -4, 3. OP. So OP is called when the starting point is the origin and the terminating point someone. So OP or OA or OB, when the starting point is origin, that is called the position vector of P or position vector of A or position vector of B. So OP is the position vector of P. So must understand what is the meaning of the position vector. If the starting point is origin, then the vector is called OA or OB or OP is called the position vector of the given point. So here in question number 10, the vector OP, we have to find the vector OP where O is the origin and P is the midpoint of the segment RS, where R is 2, -1, S is -4, 3. So question number 10. How to find the midpoint? Question number 10. R is 2, -1. S is -4, 3. So first of all, we find the midpoint. Midpoint, P is the midpoint. How to find the midpoint? Add the 2, divide by 2. 2 and add -4, divide by 2, -1 plus 3. Add the 2 components, divide by 2. So x1 plus x2 upon 2, y1 plus y2 upon 2. If there is a third component, z1 plus z2 upon 2, that will be the midpoint. So it will become -2 upon 2 and 2 upon 2. It will become -1 and 1. This is the midpoint of line segment RS. Midpoint of the segment RS. Midpoint of the two given points R and S. Now we'll find the vector OP. This is called the position vector of P. OP is called the position vector of P. When the starting point is the origin, when the starting point is the origin, then OP or OA or OB or OC or OQ, etc., they are called the position vector of P, position vector of Q, position vector of A, position vector of B, position vector of C, etc. So OP is the position vector of P. When you are asked to find the position vector, it means the starting point will be origin. Starting point will be the origin. So OP will be equal to the component of P minus the component of origin O. So minus 1 minus 0 I plus 1 minus 0 J. It will become minus 1 I or minus I and plus J. Minus I plus J. So position vector of any point, position vector of any point will be equal to that point into I plus this component into J plus Z component into K. Understood? So if X, so that question is over. Now I'm telling you, if X is a point, X1, Y1, Z1, sorry, X, Y, and Z. Find the position vector of X. Find the position vector of X. So OX will be the position vector of X. It will be equal to this component into I plus this component into J plus this component into K. This is the position vector of X or the vector OX. Position vector of X or the vector OX. When the starting point is the origin, then the vector is called the position vector. So this is the position vector of X. This is the position vector of P. So in this way, we have to find the position vectors. The vector from the point A to the origin. So first we find this is from origin to the point. From origin to the point will be minus I and plus J. From origin to the point will be Xi plus Yj plus Zk. And from point to the origin, it will become XO. It will become XO. That is from point to the origin. So we'll put the negative sign. Negative Xi minus Yj minus Zk. We'll multiply by the negative sign. So it will be the vector from the point to the origin. From the point to the origin. So we'll multiply with the negative sign of the position vector. So question number 11 is the same. The vector from the point A to the origin. So from point 2, 3, 2, 3, so position vector will be equal to 2i plus 3j. And the point vector from point A to the origin will be minus 2i minus 3j. We will multiply with the minus sign. The sum of vector AB and the CD. Find the sum of the vector AB and the CD, where vector A is 1, comma, minus 1, B 2, 0, C minus 1, 3, D is 1, minus 2, 2. So first of all, we will find the vector AB and we will find the vector CD. Then we'll add the two vectors as we have already found how to add the two vectors. First we'll find the vector AB, then we'll find the vector CD, then we add the two vectors as I have already told you how to add the. Question number 13, the vector that makes an angle theta 2 pi comma 3 with the positive x-axis. So this is the angle with the x-axis and unit vector. The magnitude should be equal to 1. So first of all, we'll find the vector which is making an angle theta with the x-axis. So that is the angle alpha is given. Angle alpha is given. With the x-axis mean the alpha is given. So angle alpha is equal to 2 pi by 3. Angle alpha is 2 pi by 3. So unit vector, we have to find the unit vector. Unit vector, the magnitude should be equal to 1. So vector, we will find vector. Vector will be equal to cos. Unit vector means the r into cos of 2 pi by 3. We will find the vector cos 2 pi by 3. So 2 pi by 3 will be equal to 120 degree. So cos minus 120 degree will be equal to 1 into minus, this is I, with the x-axis, cos alpha. With the x-axis, told the angle is with the x-axis, so it will be I, in the I direction. So cos 2 pi by 3 will be equal to under root 3 upon 2. Cos 1 upon 2. Cos 120. 2 pi by 3 will be equal to 120 degree. So you will find, you will use cos 120. Sorry, it is under root 3 upon 2, not 1 upon 2. It is under root 3 upon I. So under root 3 upon 2, I is the vector. Now we'll find the unit vector. So first of all, we'll find the magnitude. Magnitude of V will be equal to, take the square root of this one, under root 3 upon 2 whole square. It will become 3 upon 4 under root 3 upon 2. This is the magnitude. It will be divided by the magnitude. We will get the unit vector. So unit vector V will be equal to the vector under root 3 upon 2 upon magnitude I. It will become 1 only I. So I am ending the meeting. So you have to do the remaining exercise, and next time we will do the product. Now the time is 11:44. So the meeting, you some of you must have some other class. So I am ending the meeting.